Okay, in this podcast, we're going to talk about LeChatelier's principle, which is really an important topic in equilibrium, and of course, equilibrium is an important topic in AP. But LeChatelier's principle is also really important in industry, because if you become a chemical engineer and you are working on trying to improve yield at our manufacturing facilities, then your job is to use LeChatelier's principle to try to drive reactions towards the maximum completion that you can in order to save money for your company. Okay, so let's take a look. So LeChatelier's principle says when a chemical system that is at equilibrium is disturbed, the system shifts in a direction to minimize the disturbance. Okay, one way to think about this is an elevator. So imagine you're on an elevator, and there's three of you, people you don't know, three of you get out at the same time. You're going to pretty much spread out. You're going to be in an equilibrium state. You're going to go up a floor, and let's say 3 or 4 more people come on. You're not just going to stand where you are. You're going to move around. You're going to tighten up towards the back to allow those other people to come on. So those other people coming on are a disturbance, and you adjust to deal with that disturbance. So you go up another floor, and the same thing happens. You further adjust to deal with that disturbance. It's pretty unusual to open an elevator door and see 3 people all crowded together in the corner of the elevator, unless they're just having a good time after a party or something. But you're not going to see them doing that unless they have to. Okay. Alright, so another way to look at this is I have a flask here of water, and it's a closed flask. It's got a lid on it, so anytime I have water, I'm going to have some amount of vapor pressure or water molecules in the gaseous phase above the liquid. These guys down here are saying, I'm glad that they evaporated. But suddenly they're back. We're back. So a couple others, not the same ones, but other molecules decide to leave. Them coming back is a disturbance. And in order to readjust to equilibrium, some of these guys have to leave the liquid phase and become part of the vapor phase. So there are a number of things that can cause a disturbance that will affect equilibrium. The concentration of a reactant or a product, changing pressure, which comes from either changing volume or adding more gas, or changing temperature. And we're going to take each in turn and talk about them. And we'll do this over 4 podcasts total. Okay, so the first thing we're going to talk about in this podcast is concentration. So here I have an equation. I have carbon monoxide, hydrogen gas becomes methanol. Okay. So let's take a look at what happens if I add carbon monoxide. If I add carbon monoxide, imagine this is a seesaw, right? And I'm at balance. If I add carbon monoxide, it's going to shift, the seesaw is going to shift down this way. And in order for the balance to be restored, I'm going to have to add more product or more methanol on this side to get the seesaw back to where it was. So if I add more reactant, I'm going to shift equilibrium to the right. Because think about what equilibrium is. It's the ratio of products over reactants, or the concentrations of them. Right? So if I'm adding more reactant, then my K is getting skewed, and the way to get my K back to where it should be, I've got to add more product, convert more of that reactant that's been added into product. Okay, same thing if I decrease. If I decrease the concentration of a reactant, if I end up taking some carbon monoxide out or have less of it, then the system wants to adjust to get it back. And what it's going to do is shift to the left. Okay, so it's going to shift left, and it's going to be reactant favored. Okay, so let's take a look. So here I have a system at equilibrium. It's got some hydrogen, carbon monoxide reactants, and it's also got some product, methanol, right? I add some carbon monoxide. I add a couple extra carbon monoxide here, causing the system to be out of equilibrium. So what the system is going to do is adjust. It is going to take one of those carbon monoxides and a couple of hydrogens and convert it to methanol. Okay? So I don't have the same concentration of everything that I had before, but I do have, I'm back to my K where my ratio of products to reactants is stable. Okay. Okay, so likewise, if I change the concentration of a product, my seesaw is heavy on the product side now, and I need to shift back. So I'm going to shift, we're going to say we'll shift left, and I will be reactant favored. Okay, just like if I decrease the concentration of my methanol, system wants to get it back, it's going to shift right, and then products will be favored. Okay, let's take a look at that from a particle standpoint. Here I'm in equilibrium. I add a couple of methanols in here, and what happens is, in order to get my product to reactant ratio back, which is my K, some of those products convert into reactant. So I pick up a carbon monoxide and 2 hydrogens, and I lose one of the methanols. Okay, so hopefully that explains what happens with concentration. In the next podcast, we're going to talk about what happens when we have gases as we change volume or pressure. Okay.